What do you think math does whenever no one's doing it? Do you think math is thinking about us while we're off doing history or whatever? I like to think it is. But who knows what math is thinking? I hope it's a good thing. Hey guys, Mr. Shaw back here again. We're going to be doing systems of equations applications today, which means that's a fancy word for word problems. Alright? And I know you guys hate word problems and you can tell me that all you want, but we still have to do them. And the best way to do word problems is just to practice them over and over again. So all the word problems today are going to be of a general type. And then we'll talk more about different types tomorrow or whenever you guys come back to class. And, we'll go from there. Alright, so let's jump right into it. Before I do, make sure you guys are writing everything down. Okay, I know it sucks to write down all the word problems, but again, you guys have to make sure you're doing it because, again, the work means nothing, okay? If you guys don't have the word problems written, it's not going to do you any good. All right, so here we go. First one. The first type of word problem we're going to be doing is coin problems. Now, coin problems, there's always going to be like a money equation, all right, dollar sign equation, okay, and then a total equation. And actually, all of the problems today that we're going to do are going to be of this particular sort. But with the money equations with coins, it's actually pretty good because it gives you. We already know what a dime and a quarter are worth. All right, so we already know half the equation without even knowing anything else about the problem. So let's go ahead and jump right in. So it says John has $4.45 in dimes and quarters. So again, I'm going to define my variables. These will be the directions for all of them, but I'm just going to write it once. So D is going to equal the number of dimes, and I'm going to have Q equal the number of quarters. We're really just breaking out right here. All right, so then it says he has a total of 25 coins, so how many of each type does he have? All right, so pretty straightforward. Let's start with the money equation, all right? The money equation, again, a dime is worth 10 cents. So what you're going to need to do is, in order to figure out how much money, like this has nothing to do with the problem. But if I had, let's say I had like 15 dimes, okay? In order to figure out how much money I had, I'd have to multiply that by what a dime is worth, which is 10 cents. And you would find out that you had $1.50. Now, in this problem, though, I don't know how many I have. So that's going to be, I'm just going to use, the letter D to signify that for now. So you're going to multiply by 10 cents. So let's do it. So it'll be 0.10 D plus, quarter is worth 25 cents, so 0.25 Q equals the amount of money that we're dealing with. Okay, so the money is going to go with this equation, so $4.45. All right, and that's a 4, even though it connected them. All right, so now we'll do the total equation. So again, if we're talking about 25 coins total, you're just going to take the number of dimes plus the number of quarters, and you're going to set it equal to 25. All right, guys, so you guys are going to see me write it. For the first one, I wanted to introduce to you the decimal, like the way to write it in decimals. Honestly, though, if you know that the decimals are there, you can rewrite it without it, and you'll get the same answer. But what we're going to do today is we're going to multiply by 100 to get rid of those decimals. All right, so multiply by 100, okay, distribute, so it's going to end up being, I'll rewrite it below it, it's going to be 10D plus 25Q equals 445. Again, all I'm doing is just moving my decimal over twice in each category, or in each section rather. Okay, so now I'm going to cross this guy out. We don't need him anymore. And now we just need to figure out where to go from here. So I'm going to use, we can either use substitution or elimination. And I think I'm just going to use elimination for this first one, just to until you guys get kind of used to it. So again, I've got 1D and 10D, and then 1Q and 25Q. So I think I'm going to get rid of the dimes. That's going to be a little bit easier. The one thing I will point out to you is that they are both positive, and one of them has to be negative. So I'm going to multiply by -10 on both sides here. So again, make sure you distribute the -10. So, and I'll rewrite it. It'll be -10D minus 10Q equals -250. and I will cross, oh, I guess I won't cross out this one, but just know that these are the equations that we're dealing with right now, these two guys right here. All right, let's keep going. So we'll eliminate the d's, add everything else up. It'll be 15q equals 195. So divide by 15, and q equals 13, I believe. Let's check it out. So 195 divided by 15, 13. All right, there we go. So I've got 13 dimes. Or sorry, quarters. I don't know why they look like kind of like a D to me. My Q's are terrible. Don't judge me. All right, so 13 quarters. All right, that'll be. I'll write it up here so we know. So I'm going to go back and I'm going to plug it into this original equation. I know that I like the number of dimes plus the number of quarters equal 25. So I'll plug in the Q. So it'll be D plus 13 equals 25. So subtract 13. The number of dimes will be 12. And that'll do it. Pretty straightforward. Let's do another one. Same type of problem, just another coin problem right here. So in this case, we're going to be using nickels and dimes. So again, I'm going to write N is going to equal the number of nickels, and D again will equal the number of dimes. So again, remember guys, we need a money equation and we need a total equation. So it says Carrie has $6 in nickels and dimes. The number of dimes is twice the number of nickels. So this one, and actually this one isn't a money and a total equation, so let me cross out the total because we don't need it, because it gives us this one where it says the number of dimes is twice the number of nickels. So that was going to be D equals twice the number of nickels, so 2N. And now we will need the money equation though. So again, a nickel is worth 5 cents. And this one, guys, I'm going to write it without the decimals. So be really, really careful. Okay, I'm gonna pretend like I've already multiplied by 100. So it's going to be 5N plus 10D equals. Be really careful here, guys. It should be 600. All right. Now again, in this case, it's set up for substitution. So again, I've got D equals 2N. I'm going to take the 2N and I'm going to plug it in for D right here, and it'll be 5N plus 10 times 2N equals 600. So 5N plus 20N equals 600. Combine your like terms, it'll be 25N equals 600, and divide by 25. So N equals 24. So 24 nickels. And then we got to go back to find the number of dimes. So again, I'll plug in the N value I know right now. So D equals 2 times 24. So the number of dimes is 48. And there you have it. That's all she wrote. Next one. All right, so the other main type of problem you're going to see is going to have to do with tickets to plays and like games and stuff like that. You're going to see those all the time. So in this case, it says the school sold tickets for a play. Adult tickets cost $7.50 each, and student tickets cost $5 each. So there were 100 more children's tickets sold than adult tickets. So I'm going to stop right there. Okay, first, before I do anything, I want to write this equation and I want to define my variable. So I'm going to have X equal the number of adult tickets, and Y is going to equal the number of student tickets. So let's go ahead and let's just get right into it. So, oh, wow, got really dark there. Good thing I'm not scared. All right, anyway, so it says there were 100 more children's tickets than adult tickets. So again, remember that the students are Y, and the adults are X. So again, there was 100 more children's tickets, so that means that Y is going to equal X plus 100. And then, so now we've got that equation. Now again, we're going to need, it says $3,000 was collected. So again, we're going to need a money equation in this case. So I'll just write it. So it's going to be 750X plus 5Y equals 3,000. I'm just going to leave it at 7.5 because again, it's my only decimal and I can deal with it pretty easily. So again, you see the Y's by itself, it's set up pretty easily for substitution, so let's do it. So it'll be 7.5X plus 5 times x plus 100 equals 3,000. Distribute, so 7.5x plus 5x plus 500 equals 3,000. I'm going to do two things at once here. I'm going to subtract 500 from both sides, and I'm going to combine my like terms. So it'll be 12.5x equals 2,500. Divide by 12.5. So in this case, we got 2,500 divided by 12.5, so 200. So there were 200 adult tickets sold. So now we'll go back and just plug it in. So the number of student tickets sold was the number of adult tickets plus 100, so 300. So 300 student tickets. Okay, I got one more, and I think I got just enough time to do it. So let's go ahead and get into it. So it says a store sells cashews for $15 per pound and almonds for $12.50 per pound. It says Mary needs a total of 6 pounds total of both types. Okay, and if she spends $83.75 before tax, how many pounds of each type of nut does she buy? So again, I'm just going to set this up. You guys see, again, it tells us the values here, and then it says that we need a total of 6 pounds. So let's just make this C. So C is going to equal the number of cashews, and A will equal the number of almonds. So again, and you can just write the total one first. So it'll be C plus A equals 6. And then the money equation, again, $15 for cashews, so I can write 15C plus $12.50 for almonds, so 12.5A equals $83.75. So let's solve it. Again, I think with the decimals, I'm just gonna leave them for now. I think I'm gonna use substitution. So what I'll do here is I'll solve for C. So I'm gonna subtract A from both sides. So it'll be C equals 6 minus A. So this is what I'm gonna plug in for C. So it'll be 15 times 6 minus A plus 12.5A equals $83.75. Go ahead and distribute here, so it'll be 90 minus 15A plus 12.5A equals $83.75. Again, I'm going to do two steps in one, so I'm going to go ahead and subtract 90 from both sides, and combine my like terms as well. So this is going to end up being negative 2.5A equals negative 6.25, I believe. Now again, one thing I want to point out real fast is that, guys, you can't have a negative number of cashews or negative amount of almonds. Okay, it's not going to happen. Okay, so again, you're going to always get positive answers. Make sure you guys are aware of that. Here we're going to divide by negative 2.5. Divide by negative 2.5. So, and actually we've already done this exact calculation a little earlier. Negative over negative is a positive. So A, the number of almonds, or the pounds of almonds, is going to be 2.5 pounds. You can do that in your calculator if you don't believe me. So 2.5 pounds of almonds. All right. And now we'll go back to get the cashews. So use this equation right here. So it's going to be C equals 6 minus the pounds of almonds. So 6 minus 2.5. So C equals 3.5 pounds. All right, guys, I am all done. It's dark. I'm scared. I'm out of here. See you later.